Hey guys, and welcome to one more episode of Builder Nation. For today's agenda, I'm super happy to introduce Professor Maja Mataric. She's the founding director of the Robotics and Autonomous Systems Center at the University of Southern California, and a researcher focused on socially assistive robotics, which is going to be the main topic for today. So welcome, Professor. Super happy to have you here.
Thank you for having me. I'm excited to talk about socially assisted robotics because somehow or other, I ended up founding that field with some collaborators, and it's really wonderful to see it grow and hopefully make a difference in the world. So I look forward to talking about it. Okay, I love doing this because people always think that you know from the start what you're going to do, like since you're a small child, and then you just do it. And that was not true for me, and I don't think it's true for many people. So basically, you know, when I was a small child growing up in Yugoslavia, I thought that I would study languages, and that was great. I was really good at English. You can hear that I'm pretty good at English. Well, then I moved to the US, and everybody was good at English, pretty much. So that was not going to be the thing that I did. But I was always really interested in human behavior and what makes us behave the way we behave. And so I like the brain, but I really am more interested in observable behavior because it's hard to know what's inside here in the brain, but behavior you can observe and study. But then my uncle told me when I was, in high school, computers, Maya, computers will be important. And he was very right. And I was a good niece. So I listened to him and I studied computers and I studied psychology. And then I went to grad school and I did grad school in robotics at MIT. And I ended up being a roboticist, which is about behavior of machines. And it was really only later, after tenure, that I started thinking about why do I do what I do? And I realized that what I really wanted was robots to help people, which was really about understanding what people needed, understanding human need and human behavior. And that led me to sort of, starting this new field with a set of collaborators, which is the field of socially assisted robotics. And so I just want to point out that lots of people don't know what they're going to end up doing. And so who knows, and maybe the thing you really want to do doesn't exist. And then you create it so that it does exist. And so I think that's an important message. If you find a good problem in the world that people aren't studying yet, that's a great thing. That means we should get out there and work on it. So that's worked out for me, at least.
Actually, you mentioned socially assisted robotics, and something that really caught up my attention. I don't know, guys, if you're listening, that professor actually gave a TEDx talk back in the days, and it was about this topic, right? But Professor, you mentioned something that it was really interesting. You mentioned a phrase that it was something like robots care. And how is it that a machine can care for someone, How can you relate psychology and at the same time robotics?
So my motivation in robotics had always been to understand people and understand animals and understand what makes us tick. But then as I got older, I really wanted the robots to help someone. I didn't want them to just be interesting and you write papers about it, etc. And so the way I figured out how to help people was by looking at, outside of the lab, outside of papers, outside of books, going out there and talking to people who needed help. So who needs help? Well, everybody needs help at some point, but I focused on populations like stroke survivors, children on the autism spectrum and individuals on the autism spectrum, looked at the elderly with Alzheimer's. So I talked to a lot of individuals who had challenges to overcome in their lives. And then I talked to caregivers for those individuals. And, in business, that's called customer discovery, but I didn't know that. And I wasn't trying to start a company back then. I really wanted to understand the problem in order to figure out how robotics could help. So I really went at it in what's called the human-centered way. And it served me very well. I think one of the reasons that a lot of companies fail, that have startups that are like, oh, I'm going to do this thing and it's going to be great and everybody will love it. It's like, well, did you try and figure out what people actually really need? Because understanding human need is a hard question. But if you study it enough to understand it, and you create something that's trying to help that need, then you're much more likely to succeed. And I think that's why the field of socially assisted robotics has grown as well as it's grown, because we really care about what people need. When I talk to stroke patients, for example, I found out that with stroke patients, it wasn't that people didn't know how to do their exercises. It's that they needed someone or something there to support them many hours a day when they had to fail, like drop something or make it really hard. Who was going to support them? And that support was emotional and social. It wasn't physical. And that's how I understood, oh, so there is a niche where robotics can help, and it can do it right now. It doesn't require us to solve the really hard problem of robots physically helping people, because we don't know how to do that safely yet. And so really it boils down to studying the problem, finding out what it really takes. And you can't learn that from papers. You have to go talk to people. So go talk to real people and you will see, a world of problems, and then you focus in. And it's really rewarding, because even if you end up helping one person and they love your robot, oh, it makes all the difference. But let me answer the actual question, which is how. Well, the how is, if we're talking about children with autism, for example, there's some social skills that are very difficult for them. So who is going to practice with them? Who is going to chat with them and go back and forth and play games? Well, unfortunately, other children often don't play with them because they don't have the social skills. They don't, and the other kids may lack empathy, and they're young and don't know how to behave yet. So who is going to play? Well, parents will, and the therapist will do it for a couple of hours a week. But there's so many hours in a day and in a week and in a life where people don't get support. And so we develop robots that provide that extra support when there aren't people around to help. So with kids with autism, the robot helps them learn how to make eye contact, learn how to take turns, learn to look where someone is pointing, these kinds of skills that are hard to practice with other people. So that's just one example, but I can give you examples from stroke rehabilitation and from Alzheimer's care, whatever you like.
Wow, this is super interesting. And I mean, you make it sound so natural and so easy in order to find the problem and find the solution. But I'm pretty sure this took like a lot of years. Like how many years and how many people did it take in order to build what socially assistive robotics is now?
Well, you're right. The hard part is finding solutions, right? Finding problems is not hard. Choosing a good problem, of course, is always one of the tricks. But the field is about 17, 18 years old. I have to think back. We wrote the paper that defined the field back in, I want to say 04, 05, 2005. So, we're getting there, almost 20 years. And so what's happened in that time? Well, what happened was, one of the most important things that's happening is that we are moving from doing simple studies with really simple robots in the lab all the way out to doing studies in the real world. So for example, just 2-3 years ago, 3, 4, 5 years ago, we created robots that we could leave in the homes with children with autism for a month or longer. And that's an amazing feat, to create a system that is safe and interesting and useful enough to stay in someone's home for a month and help someone. And I'm sorry to say, this was not a company that did it. It was researchers. So I'm both happy and sorry. I'm sorry that companies are not, by and large, taking up these worthy products. But then I'm very proud of our students who could do that. So we moved in those nearly 20 years, we moved from lab experiments into the real world. But we need a lot more people moving out of the lab and into the real world.
Definitely. And so at the end of the day, these robots that you guys are building or that you build at some point, they are not only for motivation, but you say also for companionship, right?
Yes, exactly. That I like to call it a nexus. That intersection of what people need is really a combination of, it's this social support. We're very so as humans, right, we're very sensitive to social influences. So when someone cares about us, we tend to do what that person says and tend to want to make them happy because they make us happy. So the role of the robot is to be that companion that is available to you, that cares about you, that you feel wants to listen to you, will give you positive feedback, kind of a friend, right? But unlike human friends who have their own lives to live that are complicated and might have a bad day and might be grumpy, and so on and so forth, The robot doesn't have those issues, right? It's never grumpy. It's never having a bad day as long as the battery is charged. And probably the light is on so they can hear and see you. But the idea is that, it fills that niche where it's a buddy, a companion, a friend. And at the same time, it has goals to help you, right? So it's not just that it says, you're doing great. Well, maybe you're not doing great. Did you do your mindfulness exercise that will help you? No. Oh, well, that makes me sad. Let's do it together, right? So it's not just, it's all great all the time. No, it's there to help to kind of encourage you and push you, but just right. Not too much, not too little, right? So that's the idea.
And how do you find that sweet point? Like, how does it connect with neuroscience? That's super interesting, because at the end of the day, it's not only that you set up this kind of phrase for the robot or these specific quotes. At the end of the day, he has to understand you in some kind of way, right? Your feelings, your emotions, your attitude.
Exactly. So those are the fun parts, because that's really the hard stuff. The hard stuff is to kind of understand what matters. So for example, if I'm trying to help a child with autism, usually when we're trying to understand people in interactions, we look at their faces, right? And we try to read their faces and understand, are they happy? Are they sad? Are they paying attention? Are they looking away and being bored, right? Being distracted. But that might be very difficult for certain users. For example, if a robot is working with a child with autism, that child might not be making eye contact. They might be looking out of the corner of their eye because that's what they do. So if the robot has kind of a standard model that's been trained on data from other kids, especially children who don't have autism, it might misunderstand the child. It might say, oh, okay, well, you're not looking at me. Why aren't you looking at me? Well, that's not proper behavior if you want to help someone who is having trouble looking at you. So that's just an example to say that we read neuroscience, we read cognitive science, social science, behavior science, behavior economics, because it's very interesting about how you nudge people's behavior. So we read a lot in my lab about all of those other sciences and what they understand about the problem. So if it's autism, we read a lot about it from all the other sciences. And then we say, okay, how can we make a computational model, let's say, of engagement? What does it mean for a child with autism to be engaged in an interaction, given that their engagement is totally different from, I don't know, some other context, like elderly with Alzheimer's, right? So then you interact with the child, you collect some data, you learn, you being the robot. The robot learns that what it means for this particular child to be engaged might mean that they're constantly looking away and looking back. And that's their way of showing that they're engaged. So the beauty of technology and computing and even machine learning in this case is that we can learn to help each individual user. So it's not one size fits all. It's not like, oh, I got a big data set and I'm going to train it up and it'll work for the next kid. Actually, it won't work at all. You'll have to train on each individual child. But that's beautiful because that's what technology is for. It's for personalizing to each user, the child, the elderly person, the person with a physical disability, whatever it is that they need and whoever they are.
So at the end of the day, it seems that psychology is the one behind it, trying to predict human behavior.
Well, the problem with just using psychology is fantastic. I love psychology. I would have majored in psychology, but I back then thought, well, I don't want to be a therapist because I probably wouldn't be a very good one. But then I realized now I'm just creating all of these robot therapists. So what can you say? But the idea with psychology is trying to understand how the human mind works and why people behave the way they behave. Very rarely does it focus on how do you do health interventions, right? So there's some things in behavioral therapy, but not very many. And so what we're trying to do is we're trying to scale up behavioral therapy. We're trying to say a lot of people need a lot of help. How can we learn from human interactions that are helpful and therapeutic, and then add that with machines so that people can get help more hours per day? So for example, again, I'm going to use autism, but it works for stroke rehab. It works for everything. You are only going to get a couple of hours of therapy time per week, maybe 3, but you needed many hours per day. So usually if we talk to really caring, creative therapists, they tell us things like, wow, I'd love it if the child had a robot that would reinforce practicing between sessions with the therapist. So the idea is not that you're replacing the therapist. The idea is that you're taking the lessons that humans are trying to implement and you're just scaling them up. It's kind of like what we call force multiplying.
And does it have to do anything with machine learning? Or what does machine learning have to do with, the actual robot?
Yeah, well, machine learning has everything to do with it in the sense that the robot needs to personalize to each user, right? Because especially when it comes to behavioral challenges, there is no one size fits all. If there were a one size fits all, well, then, you could just download a list of things to do and you would do it and you'd be done. And then what? You wouldn't have anxiety, you wouldn't have depression, you wouldn't have autism. It doesn't work like that, right? Life is hard. And so there's certain things we know are probably good, but how to adapt them to each person, given what they're struggling with in the moment, that's the hard part. And so machine learning is adapting to each user, but it's not your standard deep learning. I'm going to have a lot of data and I'll generalize what I have to the next user. It's nothing like that, because you usually don't have a lot of data around sensitive interactions. And even if you did, each user is different and each user changes. They get better, they get worse, they're in a bad mood. It's adapting to people is tricky, right? We spend years making friends and adapting to our friends. So obviously it's not going to be tricky and simple. I mean, it's going to be tricky and it's not going to be simple, and it's worth the investment. But yeah, so machine learning is what makes that possible, what makes improvement better.
That's correct. And especially since we have so many diseases with so many different kind of, it's not only the different personality, but the actual disease, if we can call it like that, or the actual problem, it depends on each person, just like you're saying. And how many robots have you built? Or are they at some point of the life going to be outside for anyone in order to purchase? Or how does that work?
Well, we have developed many robots over actually more than 20 years of my career, but certainly the almost 20 years of socially assistive robotics. We've had to develop robots because we couldn't just go and buy them, right? They don't exist. There is no, I keep saying, where's the robot store? I want to go to the robot store, like you go to a shoe store, right? You go to a shoe store and there are a lot of shoes. Whether that shoe store is online or physically, doesn't matter. There are a lot of shoes and you choose the shoes you want. Well, you can't do that with robots. You can't go to a robot store and say, I need a robot that'll be appealing to children between these two ages, and it'll be safe to have in the home, and will be able to talk to me and tell me stories. Well, that doesn't exist, right? So we end up having to design, first of all, and then build prototypes of robots that we use for our studies, which is really frustrating. It's really time consuming. It's really hard. And it's really impressive that our students are able to do that, considering that our students are not mechanical engineers, they're not electrical engineers, they're computer scientists. And yet here they are building robots because they have to. So, I hope that's going to get easier. But in the meantime, yes, we do build them. We design them, first of all. We talk to users. We find out what they might like, what they are willing to accept, what is going to be interesting for them to use. And that's how we design our prototypes. And so, yes, I wanted, like everyone else, to basically design something and put it out on the market. And I did do a startup. And unfortunately, I didn't have a great experience with that because, when money is involved and investors and CEOs, they have different goals. And so, I was hoping to have a company that was all about helping children with autism, but that's not what happened. So I got out in 2018 and haven't been involved since. And I think that is really the sad thing about the startup and the commercial world out there, is that, if it's about profit, then, that's not the shortest path to creating something that really helps people, at least so far, right? Because if there were a lot of profit in this, there should be by now more companies that are creating robots for people with special needs. But that's not what's happening right now.
It's not one. Let's hope for the best, Professor, and let's not give up. I mean, I'm pretty sure that, I don't know, maybe your kids will have an era where they can go to the shoe store that it's now the robotic store, and they can find it really easy. And maybe those specific robots will be helping people just like you are building them right now.
Yeah, so I think that things are definitely getting better. And in fact, what I'm really excited about is these amazing students that we find in our field, students who are motivated to make a difference, who are motivated to work on these really compelling problems. And so that's really, it's a wonderful thing. This is why I do what I do. This is why I love working with students, because they do just amazing things. And, who knows what's coming in the next 2, 3, 5 years, because my students are going to do amazing. They're going to come in with great ideas and they're going to go and change the world. And so, yes, absolutely. I think things are getting much better. So I can't wait.
It's gonna be, and I mean, I think this totally relates with entrepreneurship. Like, how do you think that entrepreneurs can build robots or can relate into the social assistance world?
Well, I think that's a little bit trickier because basically, one, you have to actually care about helping people versus making a profit. So when someone can align helping and making a profit, that's ideal. But usually what happens is that there's a conflict. So let's say you want to build a robot that helps children with autism, but the investors think that it would be a bigger market if you made an entertainment robot. And so they really say, well, don't work on autism because that's not all kids. Let's work on entertainment, right? And that happens all the time. So that's just one example. But that's what happens, right? So I think when young people with great talent and skill decide that they want to do something, they should not lose sight of their ideals and their goals. Because if they give that up, I'm sorry to say, if they sell out, then they will not get back. That's the sad thing. Is then you end up doing something entirely different that someone else thinks is going to make more money, and then it may or may not. If it does, you're still not happy because it wasn't what you wanted to do. And if it doesn't, then, it fails anyway. Wouldn't it have been better to focus on the thing you actually care about? So unfortunately, when it comes to entrepreneurship, to the extent that support funding, has to come from some place that believes in it, we're in a world right now where, like venture capital, for example, investors, they don't care about this enough yet. But I think as young people are starting to get into the field, and also they're getting, some of the wealthy young people are getting older, right? They're starting to care more. So I'm always optimistic. Absolutely, I'm optimistic. But what I would say is, I don't want young people to be so naive that they have to hit their head against the wall to learn a lesson. If you think that you're going to go out there and you have a beautiful story about helping kids with autism and that investors are just going to come running to you, that's not going to happen. So you have to, and that doesn't mean you should give it up and go work on a burger flipping robot. No, but you have to think hard. How do you sell this thing? When we were creating the field, we had to find a need and we had to work on it, and then it emerged. And similarly for generating financial interest, you really have to think about, in a sense, you're meeting the needs of the investors. It's always meeting someone's needs. So you got to kind of figure out, how do you do that without compromising what you're trying to actually develop for the world? It's not easy, but it's always interesting and never boring.
And I'm pretty sure that you have a lot of learnings from all of your experience in the past years. But at the end of the day, just like you're saying, I mean, you know how the market works, you know how the roboticists work and what they have on their minds, what entrepreneurship thinks. So at the end of the day, it's a hard lesson, but it is a lesson that, like at the end of the day, you can teach your students. Can you tell us, or can you share with us, what is the biggest technical challenge that you have ever faced?
Well, technical challenge, I will tell you that technical challenges are nothing compared to social challenges. So, you could say, well, natural language understanding is still difficult, and I want robots to be able to understand people in real time, and that still doesn't exist. But, it's gotten so much better in the last 5 years that I'm projecting it's going to get tremendously better in the next 5 years. So that's fine. Robot perception is still really hard. So robots don't necessarily know exactly, who are they seeing? How clearly are they seeing? If the lighting changes, their perception is not fantastic. But, there are ways of getting around that, and, things are getting better. So I don't worry about technological stuff. What I worry about is social stuff. So, for example, if people don't want to invest in developing certain kinds of things, then that's a massive barrier. If people decide that they don't want to fund certain kinds of research because, for example, they're political, that hasn't happened in our field, but it's happened in other fields. And then it doesn't happen. And then that research doesn't progress. So the challenges are always much more social than they are technical. I have confidence in engineers solving problems. What I worry about is politicizing decisions and not basing our decisions on actual knowledge and data. And if there was ever a time where we saw that, it was during the pandemic.
Wow, really interesting. And a really interesting point of view. I mean, I think most of the times, I'm telling you, we look at the technical side instead of the social side. And for the last but not least, I wanted to ask you, do you have any advice for future engineers who are listening to us and that want to start on this robotics path?
Absolutely. I am full of advice because it's been such an interesting journey for me, and not over anytime soon, one hopes. So I would first of all say, it doesn't matter at all what you have done so far and whether you have the experience in the background. So that's one of the things I see as a barrier. A lot of people say, oh, well, I haven't studied this or I haven't learned this, and how could I possibly do it? Don't let that stop you. It doesn't matter what you've done until now. If there's something that you want to do in this field, you can pick up the information, you can pick up the knowledge, you can learn. So that's the first thing. The second thing I want to say is stop being obsessed with math and thinking that you have to love math and be the world's greatest mathematician in order to do engineering and robotics. It's just not true. I don't love math. I just do enough math to get to the stage that I am. Do I do any math right now? Zero, exactly zilch, right? So the point is, of course, yes, you have to take some classes and you have to gain skills, but that's not the end all. Just do it. Work hard, get through it so that you can do the thing that you really want to do. And I think it's unfortunate that there is a myth out there, and I want to bust that myth, that there's a myth that like you have to adore math to be in engineering and to be in robotics. And it is just not true. It's not true practically. There's certain parts of the field that are very mathematical, but they're just one of many things that we do. So anyway, don't believe myths. Go talk to real people. If you see someone who's doing the kind of work you're inspired by, learn more about what they do. What did they do, as opposed to, believing a stereotype. So don't worry of what you've done so far. You can still do it. 2, you don't have to love math. And then 3, do what really inspires you. And I mean that in the context of engineering in particular. So I love my job because I love working with young people. And I also love developing technologies that make me feel like I'm helping. So I had to, work to create a field that does that so I can be happy all the time. So because I couldn't find one at the time. So I think that's a really important lesson for everybody, which is if you're passionate about something, and you'll know either if you're passionate about it or you dislike something. Well, if you really dislike something, that's also a hint that maybe, you shouldn't be doing that.
Goodbye.
And so I just feel like, I really had to think about what I liked. And it was not about engineering, because what you like is not going to be an engineering thing. It's not about like, oh, I like machine learning. That's just a tool. It's not a thing you like. What is your purpose in life? Your purpose in life cannot be machine learning. That's not a purpose. So what is your purpose in life, right? And I realized for me, my personal purpose is that I want to feel like I'm developing something that helps people. That's really important to me. That's what makes me happy. And so then I was like, okay, so how can I get to that? And there are many, many ways to get to that, and I found this one through my field. But it's so important to do that. You see young people taking jobs and getting majors and studying things just because they're currently popular or they think they have to, and then you're just basically signing up for not being happy. So find a way to find the things that give you joy, to weave them into your profession one way or another, because you're going to be working for a long time in your life. And it would be good if you could be working on something that you feel good about.
Wow. I mean, I think that was the best thing in order to close up this interview. Professor, this was not only interesting, this was also inspiring. So thank you so much. I'm pretty sure that you will help a lot of engineers, a lot of young people who are listening to us right now. Really, really inspiring you. I feel super inspired, and I'm not even an engineer. So thank you so much for taking the time and for sharing what all of your work has been about and is what you're doing right now. So thank you so much. Do you have any social media handles where we can find you, where people can find or read your articles?
So actually, I don't personally. I've kind of a part of my kind of staying mentally healthy is to not be much on social media. Sorry to the folks who feel otherwise. And so, but so there's through the engineering school, there is a Viterbi handle on Twitter, I guess. But certainly for me, it's very easy. If you Google my name, you will find my webpage at USC, and it has all of my papers and it has the media articles. I'm really easy to find. I also have a kind of a unique, rare, well, not unique, but a very rare name. So nobody has trouble finding me on the web if they try with a single query.
Amazing. That's correct. I looked up for you and I was like, wow, she's on Wikipedia.
Yeah. Easy to find.
And I read, and you are also on YouTube. I mean, your TEDx is on YouTube. So that's great. Really interesting as well.
There's actually a brand new thing that has just come out. And it's on Amazon Video. I was very honored for them to do. They're doing a documentary of several scientists and researchers, and I'm one of them. So it's coming. It's out actually on YouTube and Amazon right now. So you guys can actually find. My students just told me, because I never track these things, because I don't know. It seems a little.
Professor, no, how can you not see that? Okay, this is great.
Well, I don't like to think about that, but I'll tell you what it's called. I'm just pulling. See, you would think I'd know this, but I just don't. I have
to look for it.
I do have to look for it. I'm going to look for it right now. But anyway, so there is a video on, and my whole point of doing that was really so that it would inspire people to go into engineering and do things that they love and find things that they love. Okay, it's called Remar's Luminaries, and it's on Amazon Prime and also on YouTube. So
we're definitely gonna see you there. Thank you so much for taking the time. And remember, guys, that you can also find more information, interesting articles, really interesting interviews like this one in our website, ControlHub/builder-nation. We're super happy to have you here. Thank you so much for being one more time in our podcast. And thank you once again, Professor. It was amazing to have you here.
Thank you so much.